Hi everyone, welcome. Today's lesson is on the metric system and conversions within a metric system. First, you have to be familiar with the metric base units. So mass we use grams, volume liters, distance meters, time in seconds. You're probably also familiar with English units. In English, we measure distance in many units, such as inches, feet, yards, miles. And there's 12 inches in a foot, 3 feet in a yard, 1,760 yards in a mile. The metric system is a little bit easier because it has just one base unit, and then you put a prefix in front of that base unit to represent the other units. So here are the base units that and prefixes that you need to know for this class. Go ahead and write this down or copy it from your textbook. It's also in the textbook. But you need to either memorize this or put this on your 3x5 card for a test. Now, if you don't memorize any of these, you're going to have one, too much written on your 3x5 card, and two, it's going to take you too long to solve problems. So I do suggest at least putting some of these to memory. Your textbook has a lot of great memory tools, so go ahead and read that, such as making note cards, etc. That will help you memorize. So let's look at this table for a minute. Here are the prefixes: tera, giga, mega, kilo, deci, centi, milli, micro, nano, and pico. Now, the first four listed here, tera, giga, mega, and kilo, are all prefixes that are bigger than 1 gram or 1 meter, or whatever base unit you are using. So there are 10 to the 12th grams in a teragram, and 10 to the 9th gram in a gigagram, and 10 to the 6th grams in a megagram, and 10 to the 3rd grams in a kilogram. The rest of these units are all smaller than the base unit, or smaller than a gram. So these are deci, centi, milli, micro, nano, and pico. Also note that 3 at the top are all capital letters and the rest are all small, and that does matter, so make sure you watch for capitalization. Also down here, because they're smaller, 1 decigram equals less than a gram, 10 to the negative 1 gram, centi is 10 to the negative 2nd, milli 10 to the negative 3rd, etc. Now, you may see this chart more than one way. So you may see on a chart like ours, although our chart used grams, here I used meters as an example. 1 centimeter equals 10 to the negative 2nd meters, or 1 nanogram equals 10 to the 9th grams, or 1 milliliter, here I'm using liters as an example, equals 10 to the negative 3rd liter. You may also see this in charts written with positive exponents. So centimeters is smaller than a meter. 1 centimeter is only 10 to the negative 2nd meter. But you can also think of it that there's a lot of centimeters in 1 meter. So 10 to the 2nd positive centimeter equals 1 meter, or 100 centimeters equals a meter. So you might also see it, instead of 1 nanogram equals 10 to the negative 9th gram, 10 to the positive 9th nanogram equals 1 gram. And the same thing you might see with milliliters. 1 milliliter equals 10 to the negative 3rd liters, but 10 to the 3rd milliliters equals 1 liter, or 1,000 milliliters equals 1 liter. So you may see it written any of these ways, and good to know, it doesn't matter which way you use them, because they will all give you the correct answers when you're using them to convert between centimeters to meters or grams to nanograms. So sometimes the chart may look like this instead, and you may use either, whichever you find easier to use. I would suggest memorizing at least the minimum of these prefixes: kilo, centi, milli, micro, and nano, because we're going to use them a lot. So these you should definitely memorize. Be great if you memorized them all, but these would be the very minimum. And remember, I just put this in grams. It would work with the other base units. So once you have the base units and the prefixes memorized or down somewhere while you're practicing memorizing, what happens if I want to change? What if I have a number in nanometers and I want to know how many meters that is? Or what if I have something in centigrams and I want to know how many megagrams that is, or reverse? We're going to use something called unit analysis. And unit analysis is something we're going to use all semester long. So it's good to get it down, and we're just getting a start at it right here. And unit analysis is based on some mathematical principles. So one of these principles is you can multiply any number, and here I have 5, by 1 and get the equivalent of that number. So 12 over 12 equals 1. So I can always multiply by 1. So 5 times 12 over 12 gives me 5. Because here it is going to be the equivalent, because I really just multiplied 5 times 1 equals 5. Another principle that is used is that if the number is not in fraction form, like 5, we can always make it a fraction. So 5 is the equivalent of 5 over 1. And the last thing that is used principle-wise is that if you are multiplying fractions and one number is at the top and one number is at the bottom, they can cancel out. So 5 over 1 times 12 over 5, the 5's cancel, and you get 12 for an answer. This is also true for units. So if I multiply something with units and there is a unit at the top on one fraction and the same unit at the bottom of another fraction, the kilometers here would cancel. And we're going to use that to help us decide if we multiply or divide by 10 to the third. For example, here we are converting kilometers into meters. Here we're converting 5.2 kilometers into meters. And to do that, we are using equivalence from one of our charts, and one of the equivalents is that there are 10 to the third meters equals 1 kilometer. So this basically is multiplying by the number 1 because they're equal. 10 to the third meters equals 1 kilometer. And I know to put the kilometer on the bottom of the fraction and not the top of the fraction so that these kilometer units will cancel and I'll be left with meters. So when I multiply the numbers out, 5.2 times 10 to the third, I get that number, kilometers cancel, and I get meters. So I know 5.2 kilometers is equivalent to 5.2 times 10 to the third meters. So let's try it again. What happens if I want to convert 4.85 milligrams to grams? I'm going to start with 4.85 milligrams, and I'm going to put it over the number 1 so that it looks like it's in fraction form. So now I'm going to either have memorized or I have to look up what is the conversion between milligrams and grams. What is the equivalence? How are they equal to each other? 10 to the third milligrams equals 1 gram. Or you could think 1,000 milligrams equals 1 gram. Or you can think 1 milligram equals 10 to the negative third gram. Either of those works out. So you choose which one you want to memorize. So now I'm going to multiply 4.85 milligrams by one of these conversions. The only thing I have to now do is get the units in the right place. So I want the milligrams on the bottom so they will cancel. So I either put 10 to the third milligrams on the bottom, which is equal to 1 gram, or I could equally do 1 milligram equals 10 to the negative third grams and put the fraction like that. And notice if you do the math, you get the exact same number as an answer because either works. But what does not work is if I put the milligrams on the top and the grams on the bottom. This now does not work. So you would get the wrong answer if you set it up like this. So you need to find the equivalence and then put the right units on the bottom and the right units on the top. Which ones go on the bottom? The ones that will help you cancel the unwanted unit. So now you try it. You're going to convert 8.6 picoliters to liters. What fraction are you going to use and what are you going to put on the top and what are you going to put on the bottom of that fraction? So go ahead and look that up, pause your video, and then see if you got it right. Hope you got it right. 10 to the negative 12th liters equals 1 picoliter. We'd want the picoliters on the bottom, and then we do the math, and we get this for an answer. Now, you could have also said that 10 to the 12th picoliters on the bottom equals 1 liter on the top, and guess what? You'd still get the same answer. Sometimes we need to use more than one fraction. So let's say we want to convert kilometers to meters, and we go to our kilometers to centimeters, And we go to our chart, and there's not kilometers to centimeters. There's kilometers to meters. There's meters to centimeters. So sometimes we might use two fractions. 1 kilometer is 10 to the third meters. And we also know that 1 meter equals 10 to the second centimeters. So now we can use two fractions to get our numbers. Once again, after I got these equivalents, I just have to remember to put the right units on the top and the right units on the bottom. So I want to cancel out the kilometers. So from this fraction, I put the 1 kilometer on the bottom and then 10 to the third meters on the top. And for this equivalence, I put 10 to the second centimeters on the top and 1 meter on the bottom. So the meters cancel. So here the kilometers cancel, here the meters cancel, and I'm left with centimeters. So what fraction's your turn? What fraction could you use to convert 585 nanometers to meters? Pause the video and see if you've got it right. Here it is, 585 nanometers. I have to put nanometers on the bottom, meters on the top. And you could use 10 to the negative 9th meters to 1 nanometer, or you could have said 1 meter equals 10 to the 9th nanometers on the bottom, but both give you the same answer in the end. How about another one? What fraction would you use to convert 0.0025 mega, notice capital M is not milliliters, this is megaliters, to liters? So pause the video, see what you do, and then see if you got it correct. Here we have it. 1 megaliter equals 10 to the 6 liters. I put the megaliter on the bottom and the 10 to the 6 liters on the top, so the megaliters cancel. Do the math, and I get 2.5 times 10 to the third liters. So what about the math? We haven't been concentrating on that. So 0.0025 times 10 to the 6. Remember to use the EE button. You can also think of it times 1 times 10 to the 6th if you want. It gives the same answer. Put that in your calculator and you get the right answer. You could probably also do this in your head if you want to. So now convert 6.3 times 10 to the 5th micrometers to gigameters. And what is the answer in scientific notation? So go ahead, do the work, get your calculator out, solve the problem, pause the video, and then see if you got it right. There we have it. I changed micrograms to grams, and then I changed grams to megagrams, and then I do the math, and this you can do in your head, 6.3, 10 to the 5th, 10 to the negative 6th, 10 to the negative 6th, you add those exponents together, and you would get 10 to the negative 7th. So this one you don't even need a calculator for. So, hope you're getting the hang of it. We'll practice more in class and at home. Thanks for listening.